All right, I got these three problems I'm going to do from worksheet 3. This first one over here, I'm going to take and distribute secant. So I'm going to get secant x plus secant x cotangent x all over cosecant x, and then a minus 1. So the next thing I'm going to do is change all these into sine and cosine. So this is 1 over cosine, secant is, plus 1 over cosine times cosine is cosine x over sine x. That's cotangents that by the quotient rule. And then this is 1 over sine x. And I still have that minus 1s hanging out over there. I'm going to reduce these two cosines to 1s because they're common factors. So that is going to give me 1 over cosine x plus 1 over sine x all over 1 over sine x. So I have these two fractions in the top divided by a fraction. So I'm going to take this bottom fraction and flip it upside down and multiply by the reciprocal of the fraction in the bottom. So when I flip 1 over sine up, this one upside down, that's going to be sine x over 1. I left my minus 1 off and my minus 1 off. We're going to keep that with there. Okay, and then I distribute this. I'm going to get sine x. I'm going to take this times this one way over here. I get sine x over cosine x. Plus, I take it times this first one. This sine x and this sine x reduce. They both reduce to 1. So this is plus 1, and I still got that minus 1. Those cancel each other out, and sine over cosine is tangent x. So that is the first one. The second one, I really don't have an identity that does this because the identity actually says tangent squared x plus 1 equals secant squared. But what I can do is, because this is minus tangent squared, one of those tells me that secant squared x minus, well, let's say it's this way. I know that tangent squared x plus 1 equals secant squared x. So what I can do is I can subtract this 1 over, and that tells me that tangent squared x is equal to secant squared x minus 1. So I'm going to put secant squared x minus 1. Better, yeah. I'll tell you what, I'm going to do it like you guys would. I'm going to change everything into sine and cosine and see where we are. I think this is what you guys would do. I don't think this is probably the fastest way. So this is reciprocal, so it's 1 over cosine squared x, and then over here, let's see, down here I got 1 minus cosine squared x over sine squared x, because that's what cotangent is. Now, something I noticed right here is that these two things have a common denominator already. So I can put these two tops, and remember this is minus this. I can put these two top numerators over the common denominator, and I'm going to change this plus 1 to the front of that and have 1 minus sine squared x all over cosine squared x here, okay? So I got that deal, and then down here on the bottom, I'm just going to leave this 1 minus cosine squared x over sine squared x for now. And then 1 minus sine squared x is cosine squared x. So I get 1 plus, and I get cosine squared x all over cosine squared x. And that whole thing is over 1 minus cosine squared x over sine squared x. So continuing down here, cosine over cosine, that reduces to 1, so that gives me 2 on top. That 1 plus that 1 is 2 on top. And then down here on the bottom, I got 1 minus cosine squared x over sine squared x. So this thing right here is a complex fraction. So I'm going to multiply the top by the LCD, which is sine squared x, because of that. So I'm going to multiply the top and the bottom by sine squared x. Now I have to do distributive property down here. So on the top, I've got 2 sine squared x. Then I take sine squared. I take this sine squared times that 1, and I get sine squared x. And then I take this sine squared times this one, and that gives me minus cosine squared x. So what I see right now is that I've got 2 things dealing with sine squared, and this is cosine squared. Well, one of my identities tells me that cosine squared x is equal to 1 minus sine squared x. So I'm going to take this 1 minus sine squared, so I get everything in terms of sine squared. I'm going to put that in there for that cosine squared x. So when I do that, I get 2 sine squared x on top. And on the bottom, I still have this sine squared x, and I got a minus, and then in place of that cosine, I'm going to stick this 1 minus sine squared in there. I don't know if it's going to help me or not. It doesn't really look like it's going to do much for me, but let's see what we get out of this. So I still have that on top, then I distribute this, and I get a negative and a positive. So let's see, that's going to be 2 sine squared x minus 1. What can I do with this? Let's see, this looks tricky. Hold on a second. I don't think I've made any mistakes. Let me see if I copy this thing down there. They're usually not this difficult. 24, let me check it 1 minute. Okay, I did not copy it down wrong. And check my work here real quick. That's good. Oh, I see what I did wrong. I put this in the top fraction. This is not in the top fraction. This thing is over here by itself. That's going to change everything I did past here. So that's why I was having trouble with it, because I accidentally messed up my problem. So I need to get rid of all this stuff. Okay, so that's going to help us here. So I made the problem hard because I made an algebra mistake, like some of you do. But I caught my mistake. This part was not over that, and I put it over it right here. So, okay. So I have a complex fraction right here. So what I'm going to do is I'm going to get rid of the complex fraction by multiplying the top and bottom of this by the common denominator, which is cosine squared sine squared. So I'm going to multiply this top part by sine, oops, I'm going to do a different color here. I'm going to multiply this by sine squared x, cosine squared x. And I'm going to do the same on the bottom, cosine squared x, sine squared x. So I distribute that over there to the 1, and I get sine squared x cosine squared x. When I take this times this first one, these two are going to reduce out, so it's going to be minus sine to the 4th x. And then down here on the bottom, I take cosine squared x, sine squared x times that one, and I get the same sine squared x cosine squared x. And then when I take it times this part, this sine squared and this sine squared cancel each other out. So I've got minus cosine to the 4th x, and I still have over here plus 1 over cosine squared x. So I have a common factor in the top here of sine squared. So I'm going to factor a sine squared out of that. And that's going to leave me a cosine squared x from here, because I'm taking that out. And then that's 2 of them. So it's going to leave me a sine squared x here, because I took 2 out there. Down here, I can take a cosine to the 2nd out. So I'm going to take a cosine squared x out. And that's going to leave me a sine squared. Well, that helps. That's going to leave me a sine squared x minus a cosine squared x. Now, these two are almost identical, except the signs are wrong. So because the signs are wrong, I need to factor a negative out front. So I'm going to take a negative out of this top one, which I'm going to put it in front of this sine squared x here. And on the top, that's going to give me positive sine squared because I took the negative out. And when I take a negative out of positive, that gives me a negative cosine squared x. And now I can reduce the parts in the parentheses. They reduce to ones. Oh, this is working out beautifully now. So this and this reduce. Whoops, went too far. So there's a 1 minus sine squared on top all over a cosine squared on the bottom. And then the 1 minus sine squared is also cosine squared x. So I put that in for it from Pythagorean, and those both reduce, and this answer is 1. I'm not sure that's the fastest way to get there, but it works. Okay, now this one, I see this is part of the conjugate of 1 minus sine squared, and cosine squared x does equal 1 minus sine squared x. So I'm going to stick 1 minus sine squared x in for this top part. And then that top part is a difference of 2 squares, which lets me factor this to 1 minus sine x times 1 plus sine x. And on the bottom, I got 1 minus sine x still. And I got this minus 1 still out here. So I hope you see this factor and this factor reduced to 1s. So I'm left with 1 plus sine x minus 1. And those two 1s cancel out, and that equals sine x. And that's the end of that problem. Have a good day. I'll see you later.